Welcome to BTEC Revision. In today's lesson, we're looking at vector addition. By the end, we will be able to recall the behavior of vectors and draw scale vector diagrams. First, let's talk about what vectors are. Vectors are mathematical quantities. They have both size and direction, and they are commonly represented by arrows as shown in this picture. And the direction that the arrow is pointing indicates the direction of the vector. For example, we can have velocity, force, and displacement to be a vector. In this picture, we have a spacecraft, and this arrow here could be used to show either its displacement. So we could say this spacecraft has traveled 1,000 meters, or we could use this to show the force that the thrusters are producing. So perhaps it has 1 meganewton of force, which is 1 million newtons of force. The size of the arrow is important. The size of the arrow represents the size of the displacement. So in this case, 1,000 meters. Now, if I was to draw another arrow, let's say twice as long than the original, then that would mean this displacement is now 1,000 plus 1,000. So therefore, that's equal to 2,000 meters. Now, we could be asking the question, how far is it traveled in the x direction or the horizontal? And how far has it traveled in the y direction or the vertical direction? So what we can do here is we can break down this vector. We'll say 1,000 meters, so displacement vector, into components. So this will have a horizontal or x component, and it will have a vertical or y component. The size of the arrow for x component is less than the original displacement. So therefore, the value for x is going to be less. And similarly, the same for y. We can also apply Pythagoras' theorem, because if we take these vectors, place them like so, we get ourselves a right angled triangle. So we can use that. We can also use trigonometry. So if we take this triangle and we have an angle, let's say to the horizontal, then we can use SOHCAHTOA to work out the sides of the triangle or any other angles. Breaking this vector down into components, the x and the y, is known as resolving for vectors. However, in today's lesson, we're going to be looking at solving for vectors using a graphical method. Let's start by drawing our spaceship on graph paper. And we can place a ruler next to our vector, which we named to be 1,000 meters. Placing the ruler there, we can see the length of that arrow is 10 centimeters. So therefore, we can say that 10 centimeters is equal to 1,000 meters. Now, this is 10 centimeters on the graph, okay? And it's equal to 1,000 meters in the question. So this is our key, and we can use this to work out any other lengths that we need to. So first, we can divide both sides by 10, and we can get a value for 1 centimeter. So 1 centimeter is equal to 100 meters. If you remember, the length of the arrow is very important because it represents the size of the vector. So in this case, 1 centimeter length of this arrow is representing 100 meters for the size of the vector. Now we can measure the components. Now it's important to know that when measuring the component, the end of the arrow should be completely vertical or horizontal, like so, in this case vertical, and the ruler should start at the origin of the arrow, and we can now take the ruler, and we have approximately 8 centimeters in length. Okay, and if you remember our key from before, we have 1 centimeter is representing 100 meters, so 8 centimeters is going to represent 800 meters. So this spaceship has traveled 800 meters along the x component. We can do the same thing along the y-axis, and if we do that, we should get a value of 600 meters. Let's take the spaceship and crash it into a river, which has a flow of water at 1 meter per second, and this is traveling at an angle of 45 degrees to the velocity of the spaceship, which is traveling at 2 meters per second. What is the overall velocity of the spaceship going to be? So let's take the spaceship from the previous question, and we're going to crash it into a river with a flow of water at 1 meter per second and at an angle of 45 degrees to the velocity of the spaceship, which is traveling at 2 meters per second. What is the overall velocity of the spaceship? Let's start the question by drawing the first vector, which is the flow of water at 1 meter per second. Now, I can choose which direction. I'm going to choose going vertical because it doesn't specify in the question. So how much should I draw? I can draw, looking at the ruler, 1 centimeter, but as you can see, that's far too small. So I'm going to choose a slightly bigger scale. Let's go up to 2 centimeters, and that's going to be used to represent a speed of 1 meter per second. Now it's important not to draw it too large because then it won't fit on the scale. So you can write for my key that 1 meter per second is being represented by 2 centimeters of length. So for the next step, I have to draw the next vector, which is the velocity of the spaceship. And the velocity of the spaceship is traveling at 2 meters per second. So you can see that length, 2 meters per second, needs to be drawn at twice the distance of 4 centimeters. Now, how do I draw that? It says at 45 degrees, so I'll have to use a protractor and I will measure the angle from the origin and of the first velocity vector, and that will go down to 45 degrees there. Okay, and then we'll draw the second vector. So now I'll place my ruler with an angle of 45 degrees to the first vector, as it says in the question, and I can draw 4 centimeters worth of vector, and I can label that 2 meters per second. Now we need to create a parallelogram. And in order to do that, we'll take the 2 meters per second vector and place it at that 45-degree angle above the 1 meter per second vector. Using a protractor, we can make sure that the angle is correct at 45 degrees. Now we can do the same thing for the other vector. So that's the 1 meter per second vector, and we can draw that in like so. And now you can see here we have a parallelogram. So now we can draw a straight line going from the origin to the ends there, and that is our resultant vector. Using our ruler, we can measure the length, and that looks like it's about 5.5 centimeters. Using our key, we know that 1 meter per second is 2 centimeters, so we can use 1 centimeter equal 0.5 meters per second. Then we can times both sides by 5.5. So that's 0.5 times 5.5. And this is going to give us a value of 2.75 meters per second. So for our final answer, the overall velocity of the spaceship is traveling at 2.75 meters per second. Now pause the video here and attempt this exam question. Let's start the question by drawing the first vector, force of 100 newtons. We'll start by drawing that vertically, and we'll go into the bottom left corner and draw a straight line going up, and we'll draw two big boxes. So that's 4 centimeters. and we can label that 100 newtons. And we'll draw the key on the side here, which is 100 newtons is equal to 4 centimeters in distance. For the next step, we're going to measure 45 degrees from the origin using a protractor. And now we can draw the next force vector, which is 200 newtons. And to get from 100 to 200, we times by 2. So therefore, we times 4 by 2, which is equal to 8 centimeters. So therefore, the next arrow we draw should be 8 centimeters in length. Placing our ruler at 45 degrees, angle to the first vector, we can draw our next vector, which is going to be 8 centimeters in length, and can label that 200 newtons. We need to measure the angle at which it needs to be drawn, which is also 45 degrees over here. Now we'll place our ruler there and we'll draw another vector, 8 centimeters long, parallel to our previous vector. We can draw our last vector, which is parallel to the first vector we drew. That's also vertical. Now we can see a nice parallelogram. And here we can draw the resultant vector by starting from the origin, place our ruler, going to the end of the final vector, and we can measure that length. So that's a little bit above 11. So that's about 11.2 centimeters. Now, using our key, we know 1 centimeter is equal to 25 newtons. So to get to 11.2, we'd multiply 11.2 with 25, and that would give us a value of 280 newtons. So this value of this resultant vector is equal to 280 newtons. And that's our final answer. And that's the end of the lesson. If you'd like to boost your grades, try some quiz questions at btecrevision.com. See you next lesson.